So let's take a look at hydrocarbons. As you may guess from the name, hydro is the hydrogen part, carbon the carbon part, and they're basically made of carbon and hydrogen. So carbon and hydrogen. Now, to find out how these bond, we need to look at the valency of each. Carbon is in group 4 in your periodic table, so it has a valency of 4. We'll make 4 bonds if you want. Hydrogen will make 1 bond, that's a valency of 1. So if we look at the simplest structure of a hydrocarbon, we would have 1 carbon and 4 hydrogen. This gives us a formula of CH4. And it's known as, it's a gas, and it's known as methane. This is the sort of gas you burn at home as natural gas. And if we look, there are bonds between the hydrogen and carbon, and these bonds are covalent bonds, so here and here. These are so-called covalent bonds, which means the electrons are shared. If we look at the next one, we could say, okay, let's have now 2 carbon atoms, and they would have hydrogen atoms attached, which gives us a formula of C2H6. And this is known as ethane. Again, a gas. The next one in this series would be 3 carbons, 1, 2, 3, of course with their hydrogens to fulfill the valency, and of course we would have the formula now of C3H8, and this one is called propane. And this is still a gas, of course. As you can see, this is a series. Each time we add 1 carbon to the carbon chain, and we have a name for this series. We call this a homologous series. Homologous series. And these have 3 main properties. Number 1, they have the same general formula. In this case, CnH2n plus 2. The second property of a homologous series is that the chain increases one carbon atom. The third property of homologous series is that there is a gradual change in properties. For example, the boiling point of propane is higher than the boiling point of methane. Now, when these carbon atoms join together, they can form chains, and they have this sort of structure. If we take the next one in this homologous series, which would now have 4 carbons, so we could have a chain like this, 4 carbons. Of course, with their hydrogens attached. Or, of course, it could be this shape. Still with 4 carbon atoms, of course. And with the hydrogen atoms. As you can see, these two forms are different structures, but they're made of carbon chains. And we have a name for these. They're generally known as aliphatic. Aliphatic, which means there's a chain of carbon atoms. Of course, if we look at the general formula again, we can see that this is C4 H10, and this over here is also C4 H10. The name of these two, this structure is the normal butane, the gas, and this other structure we know as isobutane. As you can see, they have the same formula, but they have a different structure. And this we call isomerization. So these are so-called isomers. Basically, they have a different structure. But they have the same formula. There is another possibility of isomers. If we take a compound like benzene, which is C6H6, and this actually makes what we call a ring of carbon, 6 carbon atoms. And 6 hydrogen atoms. 4, 5, 6 hydrogens. Which means, as you can see, that the valency of these carbons is not fulfilled. So in this one, we see double bonds forming here. So that will fulfill the valency of those 2 carbons. And then here, fulfilling the valency of those 2 carbons, and finally a double bond here. In effect, 2 electrons being shared there. This is called benzene, and basically has the formula of C6H6 and is known as an aromatic. Bit of an old name, comes from when they thought it was something to do with the smell, but we still call them aromatics, which means the molecule has a ring structure. So that's a quick introduction to hydrocarbons, looking at homologous series and isomers.